So, Assalamualaikum and a very good morning. My name is Ang Darren. Number matrix 04DAD23F1035. And today, we will be talking about the presentation on case study for subject Vehicle Dynamics DJA 50082 of class DAD 5B under lecturer Encik Shamsuddin bin Abdullah. Moving on. Here are our team members, which consists of 3 people, and that is myself, Muhammad Hilmi bin Zulkifli, and Muhammad Ali Akashah bin C. Jaharuddin. So today, our topic will be focusing on the Proton Iriz 1.6 active version, which has a compact 5-door hatchback by Proton Holdings Berhad, designed for practicality, safety, and comfort, which has an engine of 1.6L DOHC VVT with 109 horsepower and 150 Nm torque. Its transmission, which is CVT, front-wheel drive, featuring ESC, ABS with EBD, traction control, and multiple airbags around the vehicle, which is ideal for studying vehicle dynamics, focusing on the load distribution, traction, aerodynamics, and the overall comfort of the vehicle. Next, we'll be answering the 4 questions, beginning with number 1. Nowadays, many types of car brands in Malaysia suit people's needs. As a customer, you need to buy a car suitable for daily and ideal for your family's vacation. Choose one model for the vehicle you want to purchase and, using all the information, determine the static load acting on the vehicle. List all the information, parameters, and assumptions for the car. And as you can see, we got our data from the official website for Proton Iriz 1.6, which has the dimensions of the vehicle, the weight, the tires and wheels, also the transmission, performances, and engine for this vehicle. So, continuing on, we will be looking at the answer, which is, by answering the question, we write down the data we have, which is having a wheelbase, which is our L, which is 2.555 meter, the weight W 1201 kilogram times 2.81, which we get from gravity. But by doing so, we get that 11,781.81 Newton. The front weight, which means the front tire weight, WFS, is 60% of the total weight, which is 7,069.086 Newton, and the rear weight, which is the rear tire, consists of 40% of the initial weight times 11,781.81, which we will get 4,712.724 Newton. So, continuing that, we can write down the formula, which is W front weight equals to WC over L, which by rearranging the formula, we can get that C is equal to WFS times L over W, and by inserting the value, we can get that C is equal to 1.53 meter. Then, by using formula for rear tire, which is WRS is the same as WB over L, arranging it to become B equals to WRS times L over W, we can get that the final answer will be 1.02 meter. So, to confirm that our answers are correct, we can add both the front and rear weight, which is the B and the C, which totals up to 2.55 meter, which is the same as our initial wheelbase of the question. So that means our calculation for this question is correct. So that is all from me. I will let my members continue the other questions. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilmi bin Zulkifli and my registration number is 04DAD23F F1023. Question number 2. After a specific year of using the car, the tire has worn out and needs to be changed. However, there will be confusion about using the same or different tire size. As a mechanical automotive student, I will find the difference by using this tire. Compare the difference by using different sizes, either the same rim size or different rim size, or same rim size but a different aspect ratio height. And I will state the size tire that has been chosen. And there will be 3 questions. First, traction limit and traction force involved for all gear, and B, braking hypothesis, and C, brake component. For traction limit, using the formula front axle with non-locking differential, we will get 5188.31 Newton, and then we can get 4.32 meter per second square for the front, and for the rear, using the formula, we can get 3.80 meter per second square. For the traction force, using the formula to find the traction force, the low end ratio force is 2794.8 Newton, and for mid range ratio 1746.75 Newton, and for the high end ratio 931.6 Newton. For the braking and drag component, assume Iriz perform full brake with force 7000 Newton from 70 km per hour on level surface. Okay, for the deceleration, we can get 5.83 meter per second square, and the stopping distance 32.41 meter. Time to stop, we can get 3.33 seconds, and the energy 226,937.12 joule. For the power initial, using the formula, we can get 136.08 kilowatt, and horsepower initial, we can get 182.61.
My name is Muhammad Alif Akashah Becik Zaharuddin, F1033. I'm going to explain the third and fourth question. For the third question, the owner of the car wants to make some modification to improve the aerodynamic drag by upgrading the interior to ensure the airflow in the vehicle is smooth. Analyze the modification that is suitable to be done in the car. All discussion and calculation must be included in the discussion. Okay, for the first thing to be modified is front splitter. Install below the front bumper to reduce airflow under the car and create a front down force to improve the tire grip. Recommendation material is ABS plastic or lightweight carbon fiber. For the second one is side skirts, reducing air turbulence along the vehicle sides and stabilize pressure between the underside and sides. For the third one is rear diffuser, speed up airflow under the vehicle to reduce rear lift, designed with an angle of 7 to 10 to maintain laminar flow. Fourth one is rear rooftop spoiler, control airflow from the roof to the rear, reducing wake turbulence and aerodynamic drag. With the addition of the part, airflow becomes smoother and drag resistance can be reduced by 12%, increasing the vertical stability and fuel efficiency at high speed. This is the car after modification, and this is the calculation I've made. The aerodynamic benefit combined effect: reduce drag by 12%, improve vehicle stability at high speed, enhance fuel efficiency, and the material using is lightweight ABS plastic or the carbon fiber. For the fourth question, besides to ensure the passengers are comfortable while riding the car, estimate the natural frequency in front and rear suspension. Discuss the value of natural frequency for comfortable ride during driving. Does the tire size influence the comfortable of the passenger during ride the car? Okay, this is the calculation I made for the front suspension and rear suspension. For the front suspension, it's 0.87 Hz, and for the rear suspension is 0.98 Hz. The value of natural frequency is directly related to ride comfort, as lower natural frequency around 1.0 to 1.5 Hz allow the vehicle body to move more slowly over load irregularities, resulting in smoother and more comfortable ride. As the natural frequency increases above 1.6 Hz, the suspension becomes stiffer, body motion is reduced, but road vibration is transmitted to passenger, making the ride feel harsher. Therefore, passenger car like the Proton Iriz are tuned within the 1.3 to 1.5 Hz range to prove a balance between comfort and handling stability. Tire size influence ride comfort because the tire sidewall can act as the flexible spring. As larger sidewall, high aspect ratio, increase air volume and reduce the tire stiffness, allow more absorption of road irregularities, resulting in smoother ride. Conversely, low profile tire are small sides and larger rim have higher stiffness and less cushioning, making the ride firmer and less comfortable. Heavier wheels also increase unsprung mass, transmitting more vibration to passenger. Therefore, for everyday comfort, maintain the original tire size. Example, 185/50 R16 on the Proton Iriz 1.6 or slightly higher profile tire provide the best balance between comfort and handling. Ride comfortable and natural frequency. Comfortable depend on suspension natural frequency 1.0 to 1.5 Hz ideal. Front and rear suspension tuned for smooth ride. Tire sides wall height affect the comfortable. Higher aspect ratio means better cushioning. Lower aspect ratio, sportier feel and less comfortable.
So, as a conclusion, we can see that after answering all the questions, the Proton Iriz 1.6 consists of balanced performance, comfort, and safety. The front load distribution enhances traction and braking. The aerodynamic upgrades improve stability and efficiency. The tire selection influences grip, drag, and ride quality. And lastly, the suspension tuning ensures comfortable driving experience. And so, as the last slide, these are the reference we got during our making of the presentation and case study. So, and that is all from us. Thank you. We hope you have learned something from our presentation.